So this is part 2 of the video of the log periodic antenna, and in the first video I made this prototype out of a lollipop stick and some copper wire, and this worked really well. So I'm actually sticking with the same design. I'm using the same calculator to produce the finished product, but we're going to use some more substantial materials just so it's not as fragile and you can use it on a more day-to-day basis. So after I released the first video on the prototyping of the log periodic, somebody left a comment saying that you could possibly use printed circuit board for the main boom and solder the elements directly onto that. And you could, and this is one here, but one of the failure points with this is you can probably see here I've had to add some more solder to that particular joint there because the element did rip itself off the printed circuit board here. But you could probably add some epoxy to the joints around here once you've got them soldered in place, just to add a little bit more strength to it. But it does have a weakness at the actual solder joints on here. So as I just said, you can use the printed circuit board as a finished design for this, but it does have its weaknesses. So what I've actually decided to use is some brass box tubing. This tubing comes in 300mm long lengths and it's 4.5mm square. And the reason I chose box tubing over some round tube is because it's really easy to drill into the side here for the holes for the actual elements, because I'm going to be drilling a hole and then inserting the element and then soldering it in place. And if you have something that's round, it just makes it a lot more trickier to get them all nice and lined up. So this is some square box tubing, and I'll put a link in the description to the seller on eBay so you know what you're looking for. Now as for the elements, what you have to remember is the finished antenna itself needs to be quite strong. It needs to take a certain amount of abuse if you're throwing it in your backpack or you drop it on the floor or something similar to that along those lines. And what I've got here is some copper wire. It's 1.6mm thick, but even though it's a little bit thicker, because it's copper, it's still quite soft. So even when you've got the element cut down, you could still quite easily bend this. So what I've got here is some brass wire. It's the same thickness as the copper one at 1.6mm, but because it's brass, it's slightly more robust than the copper, so you could actually use this and it could take a little bit more punishment before it actually bends out of shape. Now the wire that I've actually settled on to make the elements in this video is this 3mm thick wire, and this is actually a steel wire with a copper plate finish on it. Now this is really quite strong, and I have a finished example here, and the elements, you know, you'd really have to give them some serious abuse to actually bend these out of shape. But this one here is using the slightly thinner brass wire, and again it's really quite strong, but you'd have to be careful about how you treated this, because you could still bend the elements out of shape, but it's still a good functional antenna. And another change that I've made since making the last video is I've done a little bit of research on this antenna, and I've found that if you actually slightly angle both booms, so you can see here the tapered slightly, you get a little bit more forward gain out of the antenna as well. So I've made that change, and what I've used to actually create that angled wedge in between the two booms and also isolate the two booms from each other is some cork matting. Now you can buy these from your local hardware store. This is actually floor matting, and you can buy these in packs of 10 pretty cheaply, and it's a really good source for actual using dielectrics in antennas. So you can also buy this in A4 sizes on eBay if you don't want to buy a full pack of tiles. So this is the version I'm going to show you how to make in this video, and I'm still using the same online calculator as I did in the first prototyping video, and I'll leave a link in the description below. But I've just added my little wedge in. It doesn't actually tell you to do that on that particular calculator, so everything else is just the same. But I thought in this video what I'll do is take the calculator up to its maximum and make a 12 element antenna instead of this 8 element, just to add a little bit more gain. So these are the measurements that I've printed off from the online calculator, and as for the diameter of each element, I'm just ignoring those because I'm going to use this 3mm diameter wire. But we have the actual length and position of each element, and this one is a 12 element antenna, as I've previously said. So here are the requirements that I put into the calculator to get the measurements for the elements, and my minimum frequency is 2.4 gigahertz and my maximum is 2.5 gigahertz. I put in my maximum boom length, which is 300 millimeters, and this calculator gave me a real boom length of 230. So the other 70 millimeters are for the mounting brackets, but you're not going to particularly need all that length for a mounting bracket. This isn't going to go on a long scaffolding pole, for instance, like a ham radio operator would probably make his for. So because this is so smaller, we can chop some of that off because we don't need such a great length. So the maximum boom that we're going to need to actually mount all our elements on the brass box tubing here is 230 millimeters. Now these are actually 300 millimeters long, so we're probably going to be having a little bit of waste cut off, but we'll do that at the end. And the maximum gain for this antenna with 12 elements is coming out at approximately 11.6 dBi. Now I'm going to start marking off on each boom where I'm going to actually drill my holes for each element. Now what I've actually done is I've drawn a line 20 millimeters from the end of the boom on both sides here, because that'll give me enough room to actually mount my SMA connector and a short piece of coax so I can solder onto each one of these booms here. Now the mark here, that's where I'm going to drill my very first element. And remember, each positioning of each element is actually taken from this very first element. So I've also put a mark on this side so I can measure off from there 23 millimeters to actually drill a hole for my second element, and then so on. I can just measure off on this boom from the very first element, so I can position all the elements on the top boom, and I can measure off from this little black mark here where I'm going to position all the elements on the second boom. Now I've got both booms actually marked off, ready to drill the holes. I've just put a hole punch mark on each one there, and you're better off actually splitting the two booms up and your measurements into odds and even numbers. So the top one here, for instance, that's got the first element there, which all the measurements are actually taken from, and this is all my odd numbers, and the second boom is all my even numbers. So if you actually split the measurements up like this, you'll actually do it a lot easier, and you won't get so confused when you're actually marking them off on both booms. Now I'm getting ready to drill the holes in my boom, and I said at the beginning of the video that I was going to use this 3mm wire here, but I've now got hold of some brass tubing. This is pure brass, and it's 2mm in diameter, and this is pretty strong stuff. So I'm going to swap that out, and I'm going to use this brass tubing in this build, only because I've already built a smaller one using this thicker tubing. So I'm going to use this thinner brass tubing at 2mm, and I think this will be a better material to actually construct this antenna with. So now that we've got all the holes drilled in the boom, we're now going to actually measure off and cut our elements to length. Now if you're using a thinner wire like this one here, you can actually make sure they're slightly longer than the length of the element, solder them onto the boom, and then come in with some wire cutters and cut them off to length as they're actually attached to the boom here. But because I'm using some slightly thicker wire here, the best way to actually do this is to mark it off and cut it off with a hacksaw blade, and then place it back on the boom and solder it in place, because if I tried to saw this once it's soldered in place, the actual solder joint probably wouldn't be strong enough to enable me to apply the force to actually cut this off with a hacksaw blade. And I'm using a hacksaw blade similar to this one, just a cheap hacksaw blade, because if you try and use wire cutters with this kind of thickness, you don't get a nice flat surface on the cut. So use a hacksaw blade, and then just a little bit of emery paper just to make sure it's nice and flat on the end of the element. So I've got a couple of spacers here to help me, so it's just lifting the element up off the base here, just so it's lined up nicely with the boom. Now, somebody asked the question on the last video, where did I actually measure off the elements on this lollipop stick here? And I actually measured them from the point that I actually soldered them on this lollipop stick boom here. And the reason I did that is because it's got a slight curve because it's rounded. Now, when we're dealing with a flat surface like this one here, I'm actually measuring where it actually enters the boom here, so I can use my ruler and I can butt it up to the boom itself and then measure back my 31mm for my first element, and that's not taking into account the 4mm or so that it's going to be its total length when I remove it from the boom, because that 4mm is inside the boom, so we don't count that towards the wavelength itself, because the boom is effectively the transmission line and the wavelength starts where the boom finishes here. So it's a little bit different with this one, because we had that curve there. It was just easier to mark off where I actually soldered it on, but this one we need to be a bit more precise. The wavelength starts at the surface of the boom here, so that's where we're measuring from now. So all I need to do then is, I've got my rod inserted into the boom here, put my ruler up against the boom, and I can just mark off 31mm, and then I can remove the rod, put it in a vise and use my hacksaw blade to get a nice clean cut at 31mm. So once you've got your elements cut to size, you need to start preparing your boom so we can solder those elements directly onto the boom. Now, I've given all this a good clean with some emery paper, and now I want to put some tin around the edges of the holes that we've drilled. Now, I've got my soldering iron turned up to about 450. I'm going to get some solder flowing around that hole. We just need to get some heat into it because it's quite a lot of metal, but eventually, once it starts to heat up, you can manipulate that solder around that hole, and when you get enough heat into that boom, if you just give it a little tap, the excess solder will fall through and you've got some tin all around the hole, so you can solder your element directly onto that. Now what you're going to have to do next is actually put a tin of solder around the base of each element, just slightly above 4mm from the bottom here, because remember this 4mm actually protrudes into the boom itself. And once you've done that, you can get in there with your soldering iron and flow some more solder around the base there, and when it all becomes molten and when it cools down, you'll have a really good strong joint there, so it'll do a good job of holding it in place. So I've changed the angle of the camera a little bit so you can actually see what I'm doing now. I've got my soldering iron here and I have got it up quite high, around 500, so just gonna flow a little bit of solder in. Just get that heat working into the metal, because there is quite a bit of metal there. I'll get my needle nose pliers, apply a little bit of downward force just to make sure it's all the way down into that boom. Get all that solder. So now we've got the solder flowed on that side, we'll do the same on this side. And I'm doing this a bit cockeyed to try and keep it on camera. Hopefully you'll get the idea. So all the elements are soldered in place now, and the actual solder joints, I just got in there with a little rounded file and just cleaned all the joints up just to make them a little bit neater. And obviously we'll paint this at the end, but what I'm actually going to do now is cut off this part of the waist boom that I don't actually need. So I'll probably measure about 5mm from this final element here and cut them both off so they match. So now that I've cut the waist off both of these booms, what I did is use those to measure out a length of the cork matting, and I cut a piece that was 10mm width here, and then I just drew 2 lines to taper it down to a fine point here at the end, so it's like a wedge, and it's actually a 3-degree angle from this point here. So what I'm going to do is epoxy that on the first boom, and then when that's set is epoxy the second boom on top of that, like so. So then we'll have both booms actually insulated from each other, and the cork matting plus the epoxy should be strong enough to keep both booms together. So now that the epoxy is dry, I'm now moving on to actually soldering on the SMA connector so we can actually connect to this antenna. Now I've got a very short piece of pigtail here that I've crimped onto an SMA connector, and I've arranged it in this T shape here with the outer braid and the inner core. Now I've pre-tinned both of those, and I've also cut out this shape here in the cork insulator. So what I can do is actually push that down into that shape and then epoxy the SMA connector into that cork there, and then I can solder the inner core and the outer braid directly to the 2 metal booms on the top and the bottom. Now something else I'm going to do before I actually paint this is I need to think about actually mounting this antenna, because I've made the slightly longer version of this antenna. I actually want it to sit on a tripod. Now normally I would use one of these little metal angle brackets and tap out a thread in there like I do with the biquad Yagis, but if I use that I've got to think about actually isolating it from the boom itself. So what I've done, I've actually got a pen top here. It's quite a thick pen, and I've cut it down as you can see, and I've also cut a wedge in it so it will fit on the boom there and I can epoxy it in place. But I actually filled it with epoxy as well. I drilled a hole through the center there, and I tapped out the thread for the actual tripod. So what I'll be doing is epoxying that in place before I actually paint, and then I'll give it all a coat of paint, and then we can give it a test. So to test the 12 element log periodic, what I've got set up here, I've got the 8 element pointed at the same access point as the 12 element log periodic, and I've got identical alpha cards connected to them, and I'm pulling in the data, and the 8 element is pulling around just over 60% signal strength with the access point. It's quite a distance away from me, and the 12 element one is pulling in around 80%. So that's it can give you a nice visual representation of the extra dBi that you actually get from the 12 element. Now the 8 element, according to the online calculator, should give you a dBi of around 9.90 dBi, and the 12 element should give you around 11.6. So that's roughly a 2 dB difference, and on this test here we can see we're getting just slightly over 10% signal increase over the smaller log periodic. So I'm quite pleased with that, and it's quite a steady signal. The actual block is completely red. It's only dropped out a couple of times there, where the smaller one is trying to keep up. It's doing a good job, but every now and again it will drop its signal. So I just thought this little test will give you a nice visual representation what the extra 4 elements on the 12 element log periodic can actually give you, rather than just counting the access point. So I'm pleased with the performance of this 12 element log periodic. You could clearly see in that test there that it had a 10 to 15% advantage over the smaller 8 element log periodic, but I think actually going beyond this one and adding more elements, I don't think you're going to see much more bang for your buck. I think if you started adding more elements here, you'd have the same detrimental effect that you get with a Yagi. It will actually plateau out, and then adding more will actually impede the performance of the antenna itself. So I think 12 elements is probably the sweet spot for this antenna. And one more thing I wanted to point out as well, with the tripod mount here, I did have to build up the sides a little bit with some epoxy putty, because when I first tested it, it actually started bending here in the middle and actually ripping away from the antenna itself. So it did need some support putty putting in the sides there, and probably if you've got access to a 3D printer or even a laser cutter, you could probably come up with something better than this, but it seems to be doing the job now that I've got the epoxy putty in there. So overall then, I'm pretty pleased with the way this antenna actually performs on the 2.4 gigahertz here, and it also has quite a few benefits over a Yagi antenna. For one, it's much easier to build, and it's a much more forgiving antenna, because even though we put the measurements in the calculator there for 2.4 gigahertz up to 2.5 gigahertz, so we had that quite wide band there, this antenna will actually work at a much higher frequency than that, and a much lower frequency than that. That's why they're actually used in a test setup more often than not, because this will actually perform just as well at 5.8 gigahertz, for instance. It has a quite wide band of actual frequencies that it operates over, so because of that, it is more forgiving than many other antennas when you actually come to making this. So if you're not quite so accurate with your measurements, it doesn't tend to make a big difference on the overall performance of the antenna. So again, I hope you enjoyed this video. If you did, please give it a thumbs up. Any questions or comments, drop them below. I'll do my best to answer them as always, and hopefully you'll join me on the next one.